Hello guys, this is Group Dokoker, and my name is Jeremy Jiang. In this report, we will talk about the objectives of our project and some schematics, calculations, and also how will the operations be, and some videos to demonstrate our robot. So the problem is, California has experienced many forest fires during these years. For early warning and extinguishment, we are dedicated to design a forest fire detection drone system which can cross over forests, search for fire, and extinguish small fires. Material-wise, we choose to use two microcontrollers, one Arduino Uno and one Raspberry Pi. For Raspberry Pi, it will control the camera, and the Arduino will control the rest of the robots. Here is our block diagram. As you can see from the left is our camera. It is not connected to Arduino, instead it's connected to Raspberry Pi, as I mentioned before, because the Arduino cannot actually process the data from the camera. And then the IMU and GPS will connect to Arduino, really. And we will use a PWM to control two bridges, which controls two motors. In total, that is 4 motors. Here is our schematics. There are two feedback control schematics, a system one and the flight one. For the system one is feedback control during the flight to the fire. We will have the IMU to find the arrows during the flight. And with PID calculations, we find the right rotational speed. On the right is our power distribution schematic. We have 5 stages: a takeoff, and the second check for fire, then fly to fire. After is execute the fire extinguisher, and with fly back to home. Lastly, when the extinguisher is executed, we'll fly back to home. Now, let me talk about our motion control. So basically, we will have motor 1 and motor 4 rotate counterclockwise, and motor 2, motor 3 rotate clockwise. It will balance the rotation of our robot. And then we will have 2 H bridges, links the 4 motors and our control Arduino. In between, we will use PWM to regulate the voltage experienced by each motor, which will control the rotational speed of each motor. Then we'll have gyro data from IMU with PID control to regulate the flight altitude. So we have several tests to test our control logic. It will be shown in the later videos. Now I will pass to Xianling Yan to talk about his camera calculation.
Hi, as you can see over here, you can see coordinates as the drone taking pictures on the ground. By the pixel location and the altitude, we can use a simple trigonometry to calculate the relative position or the displacement from the drone to the fire. When it detects the location of the fire, this information will pass through the cable between the Raspberry Pi and the Arduino, and all the other mechanism will execute it respectively.
Here is our codes. This includes the camera codes, the test codes of the motors, and the PID codes that controls the motors. Also the GPS codes.
Now it is the most excited moment. We're going to show you how our robot is going to work from department to department. Hello everyone, welcome to Team Dokoker's Vision Department. My name is Xianling Yan, and now I'm going to show you how our vision module is going to detect if there's a fire over the forest. As you can see, here is a big green paper to imitate the forest, and the cap in my hand is gonna be this to demonstrate if there's a fire. And here is a camera module right over here, taking cameras downward to the forest, and there's a Raspberry Pi. The Raspberry Pi is gonna tell the camera to take a picture frequently, and it's gonna analyze that picture to see if there's a fire and the location of the fire. And whenever there's a fire, the information of the fire is going to pass through the USB cable back into our group's master microcontroller and Arduino Uno. And whenever it receives the alarm or the signal of the fire, the LED light bulb is going to light up and show the location of that fire. So without further ado, let me demonstrate how everything works by the code running. The monitor you are seeing right over here is gonna to show you whatever the camera is seeing. As you can see here, the camera is taking picture of the forest, no fire at this case. Light bulb off and saying don't worry, no fire. And let's say if there's a crazy kid light up several trees in the forest, there's a fire actually happening in the forest. You can see the camera sees it by taking a picture of it. The Arduino knows it because the information can pass through this USB cable into the Uno, light bulb up, and the location of the fire. Pretty nice, huh? And right now we can, I can demonstrate you by moving up left of that cap, the location can actually change right here. 170, 109, around there, right? So the location is pretty accurate. Thank you for your time. I'm gonna pass back to the main demonstration. Thank you. Hi, this is Lian again. Over here, I'm gonna do the voiceover for my teammate Jeremy. The one you are seeing here is actually our robot, and you can see everything connected nicely. And we're demonstrating you the motors can rotate separately, and over here is our PID control. When it's tilted in a certain angle, the PID control can help the drone tilt it back to its expected angle position.
Hello everyone, this is Team Dokocorn and my name is Sicheng Lee. Here you guys can see a working GPS module with an antenna. So here is the output we got. Currently I'm in Shanghai, so yeah, the measurement is quite accurate actually.
Thank you for your time to let us share this project we are truly passionate about and wish to keep developing. Due to the pandemic, team members are now locating in different parts of the world. Team Dogocore wish all of you have a strong ending for your finals. Thank you.